How are you guys all doing today?
Doing great, thank you. How about you?
I am doing pretty good, minus being chock-a-block with work because that's the time of the year. It's all picking up.
Oh man, hope you get through.
Yeah, I got stuff due Monday, like two or three things due Monday. Just great.
Good luck, buddy. Good luck, man. You got this.
Thanks. Hosting these Sumobot meetings really relaxing for me. I hope it is for you guys at least. I find it really fun. So today we're just gonna continue going through the sensors. So I assume if I see some people who weren't here last week, but I assume you guys have maybe gone through the recording from last week, skimmed through it. If not, say something and I can just give a quick refresher. Um,
I have not, if you don't mind giving a quick refresher.
yeah, no problem at all. So basically, last week we went through basically there's three circuits in this PDF that I gave you guys. So it's in Sumo Archive. There's a Google Drive link, the only Google Drive link there. Tutorial 2, there's three circuits I'm getting you guys to design and use with your Arduino. You can see right here, this thing right here, your Arduino. It's upside down, but like it's relevant.
Yeah.
And we only got through this one circuit right here, which is the light sensor. See the little squigglies doing their magic. And interfacing that with this. There was a lot of super ultra basics, getting started with programming, while launching up Arduino IDE for the first time and starting with that. And I made sure to go nice and slow compared to last year. I just whipped through all three circuits. So instead, I'm taking an extra time out to take it nice and slow. And this time, we're going to go through this button plus LED. Kind of counterintuitive. The button and the LED are actually separate. So the Arduino can actually control the LED independent of the button, and then the button can, you can make the button do stuff in code and whatnot. So it's just kind of a two-in-one kind of thing. And then an ultrasonic sensor. So this thing basically blasts out sound waves. They hit something, an object, usually like some kind of large flat surface, and it reflects back. And you basically time how long that takes because the microcontrollers here are fast enough to do that. You time how long it takes to get back, and then what do you know? You get distance. You can get precision up to like zero 0.1 centimeters, 1 centimeter, which is amazing. So we're going to go through basically these two circuits today. I'll go over again like how to program the Arduino. I guess in the meantime, make sure you guys have Arduino downloaded if you don't already. It's pretty easy to find. Just look up Arduino IDE. I'll spell it out. Arduino IDE and download in Google. And then you'll very quickly find a download link. A very nice, beautiful Arduino.cc is the actual website. But that'll just take you right to it if you just Google a bit. So is that a good enough refresher? I think you at least know what's up, where we're coming from.
Yeah, that's actually great. One thing though, I have the Groove kit for Arduino. Will that still work?
The Groove Kit, like 1.0 Grove.
Like like the one that you get for ECS 1012, I think, or 1021. Do you know which one I'm talking about?
I do not. I took that course a very long time
Okay,
ago.
hold on, I'll show you.
Yeah, go for it. Show me what's up. Um, yeah. So also in that same kind of where that PDF is, there's some code. Oh, there it is. Check it out. Holy crap! Oh, it is the Grove kit. Okay. This should be.
Yeah, I don't. It doesn't have a light sensor or anything. It does have like a spot for light, but there's no light sensor, so it's basic stuff.
I have no idea how that works. I see there's a lot of sensors, and are they all connected? I guess on that board, or do you kind of break them out?
They are connected and you could break them out. There is a button and all that stuff. And I do like, yeah, this is it.
Yeah. So in this case, I do have a selection of parts for everybody to purchase. One of them being an Arduino kit from
Okay.
Amazon, and that has the sensors that we're using here for sure, like 200%. Um, I mean, you can definitely take what you learned here and apply it to that for sure. I won't stop you at all. There might be an ultrasonic sensor in there, but I don't know that kit offhand, so I don't have like immediate memory of what.
I
Um,
don't think there is. So I'll probably just purchase the one that you're using. How much is it?
just the Arduino kit on its own is about $40, $30.
That's pretty good. But what about
Um,
the sensors?
that includes a knockoff Arduino and a ton of sensors. It doesn't
Oh,
include motor drivers, um, and a few other parts that you might want with to build a Sumobot. 9-volt batteries, 9-volt battery connectors, and stuff like that. The exact part list, I'll show you guys again. Just this Google Drive link kind of has a one-stop shop. So it has our tutorial material for today here, and it also
okay.
has this spreadsheet here, which is our amazing part list. 3 options: option A, option B, option C, all the way over here. Um, and we can see them all added up. This is just a very rough estimate. It's actually terrible math calculation, which is totally inaccurate. But you can kind of just see relative prices. It won't add up to that for sure. So you can kind of see these are the parts, and there's an alternative for some of them, but generally that's all you need.
Okay.
If
All right. That sounds
and you can,
perfect.
yeah, okay.
Sorry, I didn't interrupt you.
No, I don't think I was gonna add anything. Like this is just 100% guarantee that you're following along, if anything. But I challenge you to give it your best shot today.
Okay, I'll try that. Thank you.
Okay. With that all out of the way, um, I can. So make sure you have this zip downloaded because this is what we're going to actually run. For you new joining us. So let's get it started with. I think I got to go in order here from the original. Things autofocus. So I'm just going to scroll through the PDF really quickly, and I'm going to see that the first circuit is the photoresistor one that we did last time, and the next one is going to be this button circuit here. Pretty straightforward. There is one flaw with our diagram, so I challenge you at this point to try and see if you can assemble it from this here. But I made a typo, a very small typo, and I will point it out to you now. If we can actually draw here. Can we draw? Oh, it's sign tool. Right here, you can see this red pin here going into the breadboard. The colors are off for my camera, or in this case, I'm using them backwards because I assembled this circuit last year. And then I'm just using the same photo. But this pin here needs to move over one to match up with this resistor. Somebody else pointed that out to me a few months ago. This just needs to move over there, and then this circuit will like 200% work, assuming you plug the other end of your circuit into the Arduino correctly, which we'll go over in a minute. But basically, this circuit is emulating both of these circuits up at the top. Here, for those in like, you'll quickly become accustomed to this if you're just starting out in engineering or I guess computer science as well. These kind of circuits. So you can see a button and a resistor, and then here we have a resistor and then an LED. Don't worry if you don't have a 220 ohm resistor in your kit. I think sometimes they're random. If you have like a 330 ohm or even like a 470 ohm, that'll work fine too. Basically, it controls the brightness of how bright the LED will be. So anything higher than 220 is okay, but not too high. Like try and keep as close to 220 as you can. because the LED might just become too dim. And just as a thing, if any of you guys want to just turn on your camera, show what's up, show what you guys are doing, working on, feel free. I totally encourage that. So we can see this beautiful circuit here. I should add, if you're struggling to follow these circuits for whatever reason up top, because you can kind of see like they're two separate, but you see here they're almost like combined, because I combined the grounds, because we can do that. The grounds can go together. This resistor on the left is our 10K resistor, and the resistor on the right is our 220 or slightly higher resistor. Yeah. Now I'm starting to consciously notice that I'm saying a lot. Oh, great. Now I can't stop. So this circuit here, I'm going to, I guess, leave it to you guys until a couple of you guys at least say that you've assembled this, gotten this far. Let me know in the chat, or feel free to unmute your microphone. I'll go nice and slow at a good pace, and then I'll show you how to actually connect it to the Arduino. Yeah. Did any of you guys from last time, from last week, actually get your photoresistor working? Because I know a few of you, Felice included, kind of gave up and said they would do it later. Did any of you guys end up getting that far?
Yes, I did it actually. I got my stuff a couple of days ago. Like I was waiting for my breadboard and stuff. So, yeah.
Oh, so you did it just recently, in the last few days?
Yes. Yeah.
Awesome. That's great. So how many breadboards do you got lying around now? You got like a pack of 6?
No. Actually, I ended up buying a kit because I thought that it
Oh,
would be much better because it comes out with like different components as well, like electrical stuff. So I thought that it might be useful like in the future. So I have currently one like a larger like a bigger breadboard and one smaller one.
ooh, awesome. Okay, I didn't actually double check if some of these kits actually came with those bigger breadboards. That's good. Um, yeah, I'm
Oh
glad you got it working.
yes, yes.
So I should say, from my very first tutorial when we did the Fusion 360, I didn't provide you guys a model of that photoresistor, so you could model it into your designs. I know it's quite early for it, but I will. That's on my list of to-dos, is to find a 3D model of the photoresistor. So you guys can like model it in. And I have like, when we do another Fusion 360 tutorial, I'm gonna cover some more of that stuff and modeling in some answers to the solutions per se. So in the meantime, while you guys wait, I'm gonna work on my own Sumobot from last week. I haven't touched it at all. I slowly reassembled it after replacing some motor brackets, and now it's in a semi-working state.
It wasn't working before, or like what are you currently working
Basically, okay, my tripod's in the way of my chair. Basically, these motor last week, I guess a few weeks ago I 3D printed some motor brackets, which are behind these wires here. They hold the motor down. Oh man, thing's so tiny. And I printed out some thicker ones because my old one broke before I even like battled even a battle bot. So I printed out some thicker ones, and I had to take the entire bot all the way apart, thanks to my amazingly efficient design. And that's what I was doing last week, and now I put it all back together.
Oh, nice.
So it's a very easy lesson learned that I need to make it, like, although I made this Sumobot modular, I didn't make it modular enough, I guess. If something went wrong on kind of like the bottom end, it was a very interesting challenge to kind of fix it. So just like a random side note, like you'll kind of see that in like laptops and whatnot, is that, you know, or at least laptops that they actually want you to disassemble. Everything's kind of like, once you remove like a top cover or something, everything's accessible. Like 90% of things are accessible. And that's like a really good design technique. And I definitely did not do that. I should also say you can totally use whatever color LED you want. Doesn't actually change much if you are concerned about that. I just kind of randomly am reminded about frequently asked questions people have asked in the past, and I just want to mention them.
Just to clarify, it doesn't matter which of the options we buy the stuff from, like all the from the Excel sheet. It's okay if we buy any of them, right?
Yeah, you kind of just pick which one you want, because one of them is more expensive than the other. Some of them are more expensive than the others.
Yeah. So I guess
as
I'll
you
just
may
choose
know,
then. Can I just pick and choose from like one and like the other? Is that okay? Or does it have to be all from the same list?
I would recommend all from the same list, because
Okay.
you probably haven't fully memorized every single part that goes into a Sumobot, and you might end up missing one. There's the risk of that. That's kind of why I made 3 lists. So there's kind of like something for everybody, depending on what you're looking for. Excuse me. So in your case, like, yeah, pick from one of the lists. I'd recommend option A for just ultra cheap budget.
Okay.
And then the second option, I think, was like the more expensive one. So
right. I'm gonna just look at the option C because I feel like it's the cooler one.
yeah.
But yeah, thank you.
Yeah, and those JSumo parts, the shipping is a little bit expensive, just FYI, and you might pay customs. Just be wary.
Will it be here by next week, do you think?
If you get the FedEx shipping, yeah, you will.
No, I don't think I'll be doing that. Thank you. I'll look at it right now then.
Yeah, take a browse. Definitely those JSumo parts are top notch, though. I will not argue that in the slightest.
Wait, the JSumo parts, right?
Yes.
Okay. All right, I'll look at that. Thank you.
Yeah, no problem. Man, I'm hearing tactile clicky buttons from somebody's mic.
Oh,
Sounds
sorry,
like good
that
news.
might be.
It sounds good. It'd be really amazing if I could host in-person meetings with you guys and show you guys how to solder and all that stuff. Amazing.
That would be pretty cool. I would love to learn soldering. That one. When do you think that's gonna be possible?
Whenever your higher ups say it is.
Oh, okay. You know, that was always a
We're
question.
at their will. Like, we don't have access to our club spaces, so we couldn't even like do anything in those club spaces. Like, let alone like a normal office where a normal meeting would be hosted.
Oh,
Like a
okay.
normal classroom or something where we'd host a meeting.
Mhm.
So we're almost like we're waiting for them to say, "Hey, you guys could go take a yonder into your club room," and then we could maybe host like a small meeting with like a handful of people in there or something.
That would be pretty cool.
Yeah, it would be if York let us. Like otherwise, outside of York, there's not really places to go.
Yeah.
Like we might take an extra step and go all in and try and plan out something. It would be quite difficult to plan out something where we all meet up and battle all our bots together. It would be amazing. In like right after exams in April, be amazing. But it takes some. It definitely takes some effort to plan, so we'd only do like one of those, maybe two, kind of thing.
It's understandable, I guess. Yeah.
Yeah. And if we were in person, there'd be other bonuses. Like you guys wouldn't have to buy kits. We would just have them ready for you guys. We could just like lend them out really easily, and we could, you wouldn't have to pay a single cent.
That would be pretty cool.
Like maybe like a $20 deposit or something. I don't know. But like it would be amazing. It would just work. Life would be easy. We'd all be having a good time. This is the best we can get. I think I got it. And I don't even need any double-sided tape. That is my Sumobot. Nice. He did it. Fully assembled minus the batteries. Hopefully it'll work when that tutorial comes when we start programming your bots. Can only hope it works. So, have any of you guys at least gotten this basic circuit kind of down here? Or are any of you guys still working on it? I'm debating if I want to move on. I know people are like waiting around.
I mean, I'm not sure about others, but I'm good.
Okay, we got one for good. Okay, thanks, please.
Yeah.
I'm good as well.
Oh, we got two for good. Oh man. Okay, I'll call it continuing, but slowly, of course. So you guys can probably still see my screen. I'm going to look at this circuit now up here, and I'm going to plug the circuit in, basically. So I'm going to take out my old circuit. I'm going to follow it. I know you guys probably have the PDF open, so I will share it so you guys can actually see my amazing screen here with this amazing setup. So basically, I'm just going to unplug these. So we don't need that. And I'm going to attempt to plug it in following the circuit. So the main thing is, in my case, the orange in my circuit here, which isn't the one in this photo, it is different. Though it looks almost the same, it's like mirrored and using different colored wires. So in my case, ground is orange, right? Yes, it is. Ground is orange, so I am going to plug that into ground, and we can see on this, there's a ground all the way up here. Damn, I need to adjust the lighting on this. There we go. So there is ground there, and there's also ground over here. So I'm going to plug in this ground over here because I know I'm going to be using a lot of these pins here. And other than the 5 volts all the way up there. So I guess it doesn't matter in the end, but that's what I'm going to go with. So now I need to plug in, I'm basically going to try and plug in the LED first. So I'm going to plug in, for me, it's the red. That red goes to the top of this R1 resistor right there, and I need to plug that into D8. So I'm going to do that. Oops, ground came out. Amazing. That's halfway there. And now we need the plus 5 volts, which means that's on one side of this button here, on its own with no resistor on the other end. So it's just connected to the button, which is yellow. And that's going to go to 5 volts. Oh boy, we got to stretch it. 5 volts. And then brown is going to be our signal for the battery. Or for the button. That's this one right. I've been pointing to a screen that you guys can't even see. D9, at least to Arduino D9, and I'm just going to plug that in. And this circuit connected to the battery circuit. You know, I just realized the bonus of doing these online is at least you guys can actually see close up. Because I think in a normal meeting, you guys couldn't actually. You guys don't have a macro lens available to be able to see exactly what I'm doing. Yeah, so now now that that's together, hopefully that doesn't take you guys very long. I'm basically gonna now try and plug it in and try and wire up the code. So I'm going to, as the last step, I'm going to plug in Arduino into my computer. You guys should have a cable in your kit as well. You just pop. We can see there are some LEDs on. Actually, turn on. We can actually see the LEDs blinking. Amazing. In your case, if you've never programmed the Arduino before, one of the LEDs will be blinking on and off at about 1 time per second. And that's kind of your heartbeat almost. It's like the default program you run on it. It runs. And if any of you guys like run into issues like programming your Arduino, there's some other debug stuff that I won't talk about. Like it might go wrong and it might not be your fault when it comes to programming the Arduino. And you just have to let me know if you have an issue and I can help. So I'm going to share my screen here. This was last week's the light sensor code. So since we don't need that anymore, we actually want to use our instead of our light sensor, we want to use the button LED. So I'm going to open that. So I'm going to open the folder. So this is the zip. I unzipped it into a place, and then I'm gonna there's just 3 folders with 3 bits of code. I'm gonna open the button LED. I can just double click it. I won't go into coding details here because I think the point is more to learn circuits rather than the code at this state. So I'm just gonna quickly program this. I'll give it, I guess, a few seconds for everybody to get to this point. Opening the code, unzipping it, double clicking on Sumobot _ button under LED. It should open in the Arduino IDE if you have it installed. If you don't, it'll be like, what application do you want to open this file in or something. Yeah. So to actually program this Arduino, I have everything set up already. So I have my board selected as, if it doesn't completely glitch out on me, I have my board set to Arduino Uno. If you have one of the smaller ones, you would set it to Arduino Nano. And then my port is COM4. In this case, you guys might be different. If you're on a Mac, it'll be something different. Any kind of computer might be COM3, 4, 5, 6, 7, 8, all the way up, depending on what you have plugged into your computer. And I think Linux will be a third thing. So I'm selecting COM4 in my case. It's pretty easy to diagnose. Try one. If it doesn't work, try the other one. There's usually only 2 or 3 here. And I'm going to program, which is the upload button, which is this little arrow that's pointing to the right. Quite simple. I know it's quite small for you guys probably on your screen, but bear with me. There's a button here. I'm going to click it, and it's going to immediately try and compile and upload immediately, all in one motion, because it's taking the code I wrote here, packaging it up for the Arduino, and shoving it on over the USB cable. And now it says done uploading. Now it should work. It says in really tiny text here, done uploading. Oh my God, guys, it worked. So basically, this code is programmed. I forgot what version of this code I was running. I'm going to turn this off so you guys can see it better. Basically, when I hold the button, the LED flashes until I let go. And then it pauses, and then it'll keep flashing. If I let go, depends on when I let go, basically, is when it will hold, kind of. So that kind of demonstrates that this button isn't actually connected to the LED at all. Like, I'm just pressing and holding right now, and it is flashing because the Arduino is running this code to say, oh, this button is pressed down. I should flash this LED or do something. In this case, all it's doing is telling you to turn one of these digital I/O lines on and off, and then the LED, of course, is lighting up as a result of this circuit. So I can, at this point, I'll probably go into more detail about the inner workings of all what you just did. It will help for sure, because when it comes time to actually kind of put your Sumobot together, you gotta be able to do stuff. You gotta be able to, or not do stuff, but be able to create a slightly different design than what I just did here, so it can fit what you actually want it to do. So get rid of that. So basically what this circuit has, and the screen, not that, but the PDF, we have 2 circuits. The point of this resistor on the LED, quite simple, it limits the current. You never ever want to connect LED directly across a voltage source, which a voltage source would be a digital I/O pin on the Arduino. Basically, when you turn it to high, it basically takes that pin and plugs it into the 5 volts. And then when you turn it to low, this will make sense in the code, low or high, on or off. If you plug it into low, it'll take it and plug it into ground. That's how kind of the circuit works. So it's acting as a voltage source in essence, and you don't want to put an LED, which is technically a current-driven device, but that's more complicated than it needs to be. It has, for all intensive purposes, infinite resistance or zero resistance. Just as an analogy in how you should treat it. So you need this resistor in series such that it doesn't overpower itself and blow up. This resistor over here, though, serves the purpose of making sure this pin, when this button is disconnected, this pin doesn't float. Floating means it's not connected to ground, and it's not connected to, or it's not connected to 5 volts. It's kind of in that middle range. Because this, in this case, D9 here, 2 Arduino D9 is actually acting as an input. So it's not, instead of doing the whole unplug thing, unplug into ground and then unplug and plug into 5 volts, it's now reading the voltage. Basically, it's like, is this voltage near 5 volts or is it near 0 volts? And you'll get a 1 or a 0, on or off, high or low kind of input. And this resistor basically serves as kind of a way to pull. The whole pull term will make sense in electrical engineering. It basically, you pull this line down to ground. And since it's 10K ohm resistor, so 10,000 ohms, it's quite high. So as soon as you press this button, which is 0 ohms, it'll basically jump right up immediately to this D9 pin will jump up to 5 volts, and the Arduino will detect that. That's kind of why this circuit exists. I don't want to get into like super details, and there's actually ways that the Arduino can actually add this resistor in for you. Very handy, but for our purposes, we'll keep it. Just do kind of the external circuit because it's a lot easier to understand, and you don't have to worry about coding and all that messy stuff and what it all means. Maybe that's just my electrical engineering brain kind of talking. But for almost all of my buttons, live example right here, I did, instead of internal, using one of the internal resistors that you can program in to use, I just manually added all my resistors. Fun times. So more into detail of code, I guess. Since I guess we have time, I assume you guys are maybe, if you're not paying attention to this, you're probably working on actually getting your Arduino to work. Again, if you have issues, say something. There's no stupid questions. That's a guarantee. Because we're all going to start somewhere, right? So this code basically serves a few purposes. Well, we know what those purposes are, but how it achieves that is quite interesting. So basically, ignoring all the comments, this is all just comments, but basically, we start off with defining a few things. This is one way of defining basically a pin number. Constant int button pin, which is our name of our pin. We can name it whatever we want, and then the actual pin number. So that was our D9 pin, and then this is our D8 pin. This is our way of basically saying, hey, these are people of interest right here. These pins are of interest, and we want to name them. It'll help when we write our code further down. Now we have some variables. These are more interesting because instead of being constant integers, that's what these little tags mean at the beginning before we actually define the variable. Be it, X, Y, Z, like in algebra. We have integers. Amazing. And you can actually change these in your code, and you can make them do whatever the frick you want. So we're starting with button state, and that's 0. So this is where it will actually save the state of the button. So when we press the button, the Arduino will first check, is the button pressed? And we'll basically get an answer, 1 or 0. And then we'll immediately place that in the button state variable. We'll go into more about how variables can work, but they are definitely the most powerful thing in programming. If you didn't have variables, then, well, your code wouldn't get very far. So in the setup here, basically there's two commands, pin mode and pin mode. Basically, what are these two pins that we're actually trying to program doing? So we can see how LED pin is an output because we're actually trying to supply something, a signal to the LED pin. And then button pin, as we talked about earlier, is an input. We want to read what is that voltage coming back? Is it closer to, in this case, it's binary. So is it closer to 5 volts or closer to 0 volts? If, closer to 5 volts, we return a 1. If it's closer to 0 volts, we return a 0. Or the Arduino will say 1. It'll just basically yell out 1 or yell out 0 to you, and you got to do something with that. So we have our now setup only runs once, as we can see. Whatever inside of these brackets runs once. Void setup, ignoring that weird bracket thingy for right now, and our little curly braces. That's kind of a function, as you would call it. I'm trying to think of a very simple way to explain this. It's a function. It'll only run once. You see this in Arduino coding all the time. You have void setup and you have void loop. It'll basically get here, run this once, and then whatever in loop, it'll run till the end of time, until you unplug the Arduino or it dies or blows up or something. It'll run as long as it has the capabilities to run. It'll run. It'll go all the way through the loop, run through every bit of code, get to the end, and come right back to the top. And just go down and down. So at the top of the loop, we're basically going to keep in mind we're running it all the time. It runs quickly through this loop as well, I should know. It'll probably do this loop a few thousand times per second. More than you'd need to think in this case. Unless there's delay statements, like we can see here, or there's a lot of code in this statement. For me, I made myself like a GPS little clock. It could set itself using GPS. It was quite cool. It had a main loop of pushing probably 500 lines of code. It was running at about 120 times per second, maybe 60 times per second, maybe even less. It was quite slow. It was pushing the Arduino to its limits for sure. Just kind of get your kind of head in the game about like what does speed mean? Like how fast is this going? Do I have to can I count it? Can I not? In this case, no, it's very quick. So this code is kind of fancy because we're doing this whole press the button and then it'll flash. Just as kind of like a demonstration that yes, the button and LED are separated, as I said before. So like its first step is to check what is the LED state basically. Is it 1 or is it 0? So we can kind of see, since we set LED state at the top to 0, when this loop the first time it goes through this loop, it will basically LED state is 0, and then it'll digital write this pin to low. So it basically digital write is basically saying, what do you want me to plug? We want to take this pin. Do you want to plug it into, what do we want to plug it into? Ground or 5 volts. So digital write, what pin? In this case, for all intents and purposes, this is 9, right? LED pin is the 9. So it just replaces, basically, we're taking that LED pin, we're putting a 9 in there, and then we're putting it to low. So it's off. As simple as that. And then after that, we'll actually read the button state. So this is kind of all related to the button. It's quite simple. All it really does, there is a lot of comments in this code because of previous versions and stuff, and you got to learn to kind of ignore that. That's anything with this double slash. It's just comments. It means nothing. The code ignores it. So we see button state here. So instead of doing digital write, now we're doing digital read. But digital read is very simple. It's like you're going to get a 1 or a 0 back. All you need to know is what pin do you want to read. So in these brackets, we basically put digital read, no space here, brackets, button pin. Because that's what we defined up here, is the button pin is 9. Oh man, I mixed up the 9 and the 8. Oops. But yeah, so basically it puts in here, it takes, the code will just replace this with 9. As simple as that. Digital read, button pin 9, and you'll either get a 1 or a 0. 1 being high, 0 being low, but you can also write high or low and it'll kind of auto-translate that for you. Make your life a lot easier. And then we can see we have basically our actual code that actually says, so the button's pressed. Now what? It's kind of like every single little thing that you do with coding, you got to define, you got to tell it what to do. Otherwise, it's kind of like the computer is kind of left in the dark. It's like, oh great, I know that the button is pressed. And then it does nothing. So this is an if statement here. We can see in more brackets, basically, we can see here, if button state equals high, wait 200 milliseconds. That's part of kind of the code. And then LED state equals the opposite of whatever. Damn, I made this code more complex than I should have. But we're going to learn this. So delay 200. So first of all, if statement. Button state equals high. This double equal sign is basically equating. So for basically, it's basically Boolean algebra. So Boolean algebra basically, in this case here, what's ever inside the brackets, you're going to equate it to true or false. And true meaning 1, false meaning 0. So button state equals high. So if, let's say we press the button down, button state will in fact equal high from this, this digital read here, because we actually assigned it button state now equals digital read button pin. We just stored that value. Amazing. And now we need to do something with that. And now we know it's high because we pressed down the button. So this will in fact equate to true. And that means it'll progress into those brackets. Right into these brackets, which is these two lines of code here, which is wait, delay 200, which it'll basically just sit in this right here for 200 milliseconds. Because what in this case the delay statement is in units of milliseconds, quite handy. So 1,000 would be 1 second. And then we have LED state equals not LED state. So this is another Boolean algebra thing where if we put a little exclamation point in front of something, we could even change it to an exclamation point here, does not equal, basically. Exclamation point just means not. So basically what we're doing is we're changing this, whatever it may be, a 0 or a 1, and we're just switching it. If it's a 1, make it a 0. If it's a 0, make it a 1. That's all this line does. And we'll kind of quickly see there's nothing else here. This else statement doesn't actually do anything. This is, again, commented code from previous versions. It'll basically cycle back up to the top of this loop, and then it'll quickly be like, oh no, LED state is 1 in this case, and it will make the LED high. As simple as that. That's how code kind of is structured and the way it kind of progresses through. And this is kind of like ultra simple step 1. I won't talk about the ultrasonic sensor when we get there, but hopefully this is good enough. Because it's more complicated code, and I recommend just copying and pasting it, which I guess we're going to start doing now. Do any of you guys need more time on this topic or have any questions? I'll take that as a no. And we're going to try and do the ultrasonic sensor, my favorite one. So we can see here our beautiful ultrasonic sensor, which you guys will grab out of the box. and it will basically look like such. It's quite straightforward to a point, ignoring all this. Basically, we got a microphone, and we got a speaker. Speaker sends out ultrasonic frequencies, probably in the realm of about 200 kilohertz. Human hearing can go up to about 20 kilohertz, just for reference. And then you get a microphone that will actually detect that, and then you got a ton of fancy circuits doing all the hard work for you and turning that into a pulse. You send it a pulse to say, hey, send out a signal, and then as soon as it gets a pulse back, it'll send a signal back to the Arduino. As simple as that. So we can see here, ooh, this doesn't want to show it. There we go. We can see our pins, VCC, trigger, echo, ground. So VCC and ground, those are power, your positive and your minus, or your 5 volts and your ground. And then you've got trigger and echo. So basically, the Arduino will pulse trigger. Basically, all we do is we send it a pulse, and the code will do that for you. Send it a pulse, so it'll just quickly go to 5 volts and then quickly go back down to ground. And then all these fancy circuits will detect that and send out a few pulses. It actually sends out like 5 or 6, but we can ignore it. For all intents and purposes, it sends out a single pulse. And then, it bounces off an object, it comes back, and then you get, as soon as it comes back and gets read into the microphone, I don't actually know which one's which. I think they might look the same, but do different things. It'll pulse. This thing will now send a pulse back through the echo pin. It'll go pulse up high and then back down to ground. And we're going to take advantage of that using the code. A few things I should add is this code can kind of be a bit of a pain, because basically you send it a pulse and you wait for it to come back. But what happens if the pulse never comes back? What do you do then? It's kind of a problem. So we have to have some code in it such that there's actually a timeout. So it'll be like, oh crap, no pulse has come back. If a pulse comes back now, the object, whatever it may be 2 meters, 2, 3, 4 meters away, maybe 10 meters away, which is way farther than we can ever care about. So we just got to move on and keep doing other stuff. So that's kind of one of the problems with the ultrasonic sensors, and you have to definitely consider that. And I will definitely show how to consider that in the code. So I'm going to start by hooking it up. I basically have some wire here. This has way more pins. I think it has six cables. If you didn't know, you can actually just pull these apart. I like to keep them kind of together because they're kind of more condensed. But I'm only going to use 4 in this case, and I'm going to plug all 4 into here. Bada bing, bada freaking boom. Ta-da! And now they're in. And now we have, ignoring my gross mess of 6, we should have 4 among these, because I didn't plug them in. You can kind of see my green and my blue didn't plug in, so I'm just going to ignore them. And now we got 4 pins here. And I'm going to unplug my Arduino. That's pretty important. You should probably, if you're ever doing or you're tweaking with connections on the Arduino, unplug it from the computer. So I'm going to now unplug that, and I'm going to try and hook it up. Since you guys don't need to actually make a circuit, mine is actually just plugging it in. It should be quite simple. So I'm basically just going to unplug these. You don't need those. Get those screwed off. And we're going to try and actually plug in the circuit. So I'm going to start with my VCC, which you can actually very clearly see, which is the most left one, is black. and then our ground is purple. So I'm going to plug in our black into 5 volts on our Arduino. And then I'm going to plug our purple, which is going to be our ground, into ground. And now we have our 2 other pins here. Well, which ones do those go into? So I'm going to go back into my PDF and see what I used in code. I used D2 and D3. Okay. So I'm going to go plug in into D2 and D3. D2 for echo, which is gray. So 2. And then my echo pin, or my trigger pin, is white. And it says in the PDF that we should set that to D3. So I'm just going to plop it in there. Bada bing, bada boom. We now have our circuit. And now it is as simple as that, and it is ready to be programmed. So I'm going to give that a shot here. Oh man, we've already been going at this for an hour. I'm going to plug that in, and now I'm going to pull up the other code. I'll do it nice and slow so you guys can catch up. You guys can probably guess where this code is going to be located. Sumobot ultrasonic. I just realized I have spare light to solve all my lighting problems. Lighting problem solved. Yeah, that looks good. Okay, so now I have this code up. I'm literally just going to try and press program and see what happens. It should work right out of the box, unless I'm crazy. So there's a very high chance it may not work. And it's done uploading. And distance 0 centimeters. Oh, that's sad. Oh.
What does that mean?
That means my circuit's wrong. And so here, I'll probably quickly fix this, but as a diagnosis tip, you know if the ultrasonic sensor is working, although it's ultrasonic, you can actually hear a little bit of clicking. Every time it sends a pulse, you'll hear a very faint click, 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 click.
Yeah.
Every pulse, and I gotta actually try and listen to that. Minus my camera's autofocusing is really not helping me listen to it. Oh man, I'm not hearing anything.
Could it be like that we switch the microphone and the speaker? Is that possible?
You know what the answer is? It was right in front of me the whole time. I got my pins wrong in the code. So my PDF said 2 and 3, and my comments say 2 and 3 here, but I had it set to 8 and 7. Okay. So let's change those back to 2 and 3. And we'll save that and upload that, and it should work okay. That was unfortunate. So you notice my diagnosis step first was check hardware connections and then check software connections. I was actually going to try and make a point there. usually your first train is to check your connections. If something isn't right, check your connections. Be it software, be it hardware. That's your best bet troubleshooting. Is it working now? So it uploaded. Hey, there we go. Now we have these numbers, 150 centimeters. That is how far my ceiling is away from me, or from the sensor. So if I put my hand in front of it, can y'all guess what's gonna happen?
It should decrease to like 10 or 5.
Bada bing, bada
Yeah,
boom.
that's so cool. That's really cool.
And I made sure to put my hand above it, about 10 centimeters above, just for you. 10 centimeters. Hey.
Thank you. That was 10 centimeters exact. That was very impressive. Nice.
So yeah, so we have now an accuracy of about up to a centimeter, which is quite good. Which is really useful for hunting bots, other bots on the map. You aim it forward. If you see an object that's pretty close, like within a meter, go for it. But also, as a compromise, hot tip, guys, you can actually, if you cover yourself, your robot, in something fluffy, really soft, like a Swiffer or something, like really cottony and soft, it'll absorb the ultrasonic rays. And anybody who's trying to use ultrasonics to hunt you down, they got nothing on you. They can't see you.
Wow, that's pretty smart.
So could you do that, or would that not be allowed?
It would technically not count as jamming somebody else's signal. It's just literally the design of your dot. And also, since it's fluffy, it would fit. It could go technically over the 10 centimeter by 10 centimeter limit. But the way they test it is by shoving your little bot in a cardboard tube that's 10 centimeter by 10 centimeter, so it'll just squish down. But yeah, you can totally do that. It doesn't count as jamming.
Has anyone done it? And like, or like,
That's how I found it out.
Oh,
My friend who did Sumobots back when we were in first year told me about that hot strategy, and I do very much want to share it with you guys.
How many people use like ultrasonic to hunt down the other bots, or like are there other methods that they use?
The only other method that I mean you can use infrared. I'm not covering that here at all, but you can do infrared sensors. The only other option is brute force, which is what the winning Sumobot, I was going to pull this out from last 2018. It has ultrasonics on it, you can see, but the final code actually didn't use it. All it really used was sensors on the bottom, which are equivalent. They're just more expensive, but they're equivalent to those light sensors from the first Sumobot sensors meeting. And basically, all it does is travel along the board. It sees the edge of the board, which is a white rim, which is much lighter, high contrast, very easy to detect. It'll just turn around and go. It'll eventually cover the entire board. Well, basically, the other bot might be chasing or whatnot, and you'll eventually hit it. Or it's just almost like randomness. And the fact that the board is quite small. That's the other strategy. If you're not hunting a bot, you could go brute force.
I see. That's pretty cool. And also one other question. So since it's using a speaker to detect the distance, like doesn't the sound make like a how straight is the distance that it is recording? Like,
oh, so you think it's not going to come up directly? Yes.
Well, if it does
It's
come
not
up
gonna come up.
directly, but like, what if something were to like if it were to approach from the side, when will it start detecting it?
That is a really good question. So these ultrasonics are quite directional, but they come out, and I think it's a cone. You kind of have to estimate. Like you can see, I can put my hand about here. I think. Oh, 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 oh. Okay, I'm already over it. Maybe from the side. It's kind of hard to say, but it's about a fifth of a 30-degree cone.
It's a 30-degree cone.
So if you were to measure the angle from one side of the cone to the other, it would be 30 degrees, or you could say 15 degrees from the center. So if you measure a direct line straight up, maybe from the center of the ultrasonic, you'll get like 15 degrees out. And
Okay.
It's in the data sheet. If you actually look up this model number, HCSR04, I think that's one of the main points they say. It's like the propagation cone or something like that.
So like in the model that you just showed us right now, there was 2 of them on each side. 2 of the ultrasonic scanner, the sensors on each side, right?
Yeah, so this is, of course, not my design, but I think the intention was basically if you see a robot on your left or on your right, turn that direction and go for it, basically. As simple as that. If it's behind you, well, you'll end up running into, just go forward, you'll run into the edge, turn, and you'll end up seeing it eventually, kind of thing.
And like the hunting, how does it work? The hunting just works in a way that you have to hit the other robot, or like, how does it work?
What do you mean hunting?
So you said if you're hunting a robot, so like in that sense, if you're hunting a robot, like in a competition or in whatever case.
Oh, what's like the
objective?
Case, the win case, yeah.
Yeah.
The win case is you push the other bot off of the ring. I think at least like half the bot off of the ring.
Okay. Oh, I see. And how big is the ring?
Well, I can show you.
Oh,
I have it over here. Oop. Okay. I will switch over my camera to my regular webcam. Man, this thing is big. It is about a meter across. A little
pretty big.
less than. But I mean, relative to a Sumobot.
Oh, I see.
It's
okay.
Not that big.
That's pretty cool. That's pretty cool. All right, then. Thank you for showing us. That's a very nice squid, handsome squid you got in behind you.
Thank you. My credits to my sister for painting it for me.
Nice.
As you can see, my Discord profile picture is the same.
Oh, nice. Man, thank you so much for showing us. Appreciate it.
Yeah, no problem. And it was one of the things I got access to the Sumobot. Oops. I got access to the our lab once last September, and that was one of the things I had to grab. Like, no questions.
Huh.
It's like, frick, I gotta demonstrate this to everybody, even though I haven't actually used it on the bot yet.
Oh.
Unfortunately.
Unfortunately, yeah. All right, sir. Well, it was nice talking to you this session. I need to go get some food because I'm really hungry. So is it okay if I leave now?
Yeah, leave whenever you want. No pressure to stay. Have fun eating. I think we're almost done here anyways. I'm curious if everybody's got an ultrasonic sensor working. If not, I know you were just following along, I think.
If it's fine, could I share my design, which I've come up with for my Sumobot?
Yeah, go for it.
Okay, so can I share my screen?
You should be able to, yeah.
Okay. So right now it's like still like, you know, the first design. So like if you can remember in the beginning, I said that I wanted to make a robot, you know, which can expand. So I thought of a much better way to expand it because you said there's no limit on the height, right? So as you can see, I would have like a 20-centimeter metal beam, right? And when the bell starts, it will turn 90 degrees. So now like it will be big like this.
That is a very creative design. Oh my gosh. I like that.
And like I was also thinking instead of having 2 things to side, I could have a servo motor with a ultrasonic sensor on top of it, which could like kind of scan the area. But like other than that, I just have the sensors which just sense if it's going on the line or not. and nothing else really.
I'd recommend doing like maybe two, let's say, I don't know, like two sensors, or like the servo on the ultrasonic is cool, but you might have difficulties coding it. It's possible for sure, and also reaction time might be quite short because these bots move quite fast when it comes to the ring, and the servo might not. Is my point.
Okay,
That's
yeah,
the
because
only issue I see. But otherwise, that creative plate flipping, not that at all. I'm not sure how it'll flip down, or there's enough motor torque to flip it down, but maybe you'll manage.
I was thinking like I could have a servo motor here because it just needs to turn 90 degrees, so you could just do that.
Yeah, a servo motor would probably have enough torque for sure. It would have enough torque. So it's clear. I think it's. I think once you build it, you'll quickly realize, and you'll definitely learn. There's a lot of little things that you might run into.
Yeah, like the building will still be a process where I will keep tweaking the design as it like to make it better and to make it work.
Yeah, okay. I like your design though. I really do.
Thank you.
Did you get your ultrasonic sensor working?
Yes. So like I'm already kind of used to the Arduino stuff because like in high school I attended. It's not really. It's kind of like a Sumobot competition, but it's like yeah. So I had to use a ultrasonic sensor for that.
Oh, that's cool.
But like it wasn't kind of like a car. It was already like basically a pre-made robot, and we just had to code it. It was like a kit which we just had to build up. So it wasn't like this.
Oh, I see. A little. Of course, it would be a little easier for high school, of course. Felice, are you making out okay over there?
Yes. Mine is working.
Amazing.
Yeah, so works well.
Did everybody else get to it? Emmanuel I want to say, or anyone want to say?
Yeah. Hi. Yeah, it's actually my first session, so I'm actually didn't do anything.
Oh, okay. You're just following along.
Yeah, I'm just watching the recording. Yeah.
Oh, okay. That's great.
I'm just following along too.
Okay, that's good. Good to see you guys following along. Okay, so I guess if everybody has gone at working, or at least follow along, this is all I have, I guess, to present today for the tutorial. So this kind of covers basically all the sensors that you might use. Unfortunately, I don't have infrared to show off or anything, so you kind of have to work with that. Infrared is quite easy. Actually, oh my God, I forgot. It is the last page. So if you get the fancy edge sensors, here we go. Share my screen. This is basically what they look like, kind of close up, minus a little screw hole. But basically, it's as simple as 3 pins and an output, and it acts like a button almost. Like a button that doesn't need a resistor or anything. All it does is if it sees white, it'll output one, and then if it sees black, it'll output 0. Or vice versa, I can't remember which. And it's literally as simple as that. And infrared sensors will work I'm pretty sure they'll work all the same, just like that. And that's how you kind of do the edge detection. Basically, you get a 1, do something, be it turn around or whatnot. So for next meeting, let's actually take a look at the schedule that I actually made, and I will actually follow. Yes, October 21st, we'll make your motors go burr. That'll be a fun one. We'll actually try and get our motors spinning. We'll actually use some circuits, do some fun circuit stuff with the motors. It'll be the same circuit for the fancy motors and the regular motors, so it's not, it's nothing crazy at all, no differences. And then after that, it will be a simple Q&A session, because I know you guys got a lot of either catching up, midterms, stuff to do. Totally understandable. And it's just a time for you to work on your bot. Drawing up designs, trying to get the circuits working so you can maybe move forward with designing something in Fusion, or be it start cutting out cardboard or plastic or something. It'll be a good place for that. So if you guys don't have any more questions, I guess we can close it off here. Also, if anybody else wants to share their designs that they're working on, like, I'm totally open to it. I'm really curious to see what people are thinking, what they have in their head. Doodle it out however you wish. I'm kind of curious. I really am. How long will it take the JSumo stuff to show up? So there's like 2 shipping options. I think one is more like in the range of 2 weeks, and then the other one's going to be like 2 days. I gotta double check that. They're not. They're very vague until you actually get to the order section. But there are 2 shipping options. One's obviously more expensive than the other. Let me take a look for you. I think I'll stop the recording here at least.